So for an inductive circuit, I'll have to go back and draw the phasor diagram for a resistive circuit. So I made a mistake on that. So let me go back and draw the phasor diagram. The phasor diagram is going to be like this. The voltage and the current will be on the same line. So this is going to be V arrow on this direction, and I'll use this line to represent the current. I arrow. See, they are in phase. They move along the same line. Okay. So let's go back to our inductive circuit. So for our inductive circuit, in this case, the voltage leads the current, or we can say that the current lags the voltage by 90 degrees. So they are both 90 degrees out of phase. So the current is fast, the voltage is faster than the current. Each time you put the switch off the circuit, the voltage will be in front, while the voltage remains behind. So in this case, the voltage V of t is equal to V naught sine omega t. Okay, then the current I naught will be equal to V naught sine omega t minus theta, minus phi. So my phi here is called the phase difference. And for a purely inductive circuit, phi is equal to 90 degrees. So that was what I said. So I naught is equal to V naught sine omega t minus pi over 2 in radians. Okay, so that's the formula for the current. Okay, so that's how you get this is I V naught. This is I naught. This is I naught. This is I of t. Okay, and this is I of t is equal to I naught, not V naught. Okay. Then, in this case, the inductor has a reactance. Okay, the inductor has a reactance. So, in order to make the video to be brief, I'll just have to look at some parameter. The reactance X of an inductive or capacitive circuit is the opposition is the resistance, the opposition or resistance offered to the flow of current by a capacitor or an inductor. So for an inductor, the capacitance, the reactance is XL, and that will be equal to 2 pi FL. L is the inductance. You know what 2 pi, that's omega. So you can also write this as omega what? L. So that's the reactance. And this reactance can also be expressed as XL. Okay, I said XL is equal to 2 pi FL or omega L, because omega equals 2 pi F. Then XL can also be equal to VL all over IL. That is the current, the voltage across the inductor divided by the voltage, the current across the inductor. Okay, so if we represent the sine wave, so we're going to have something like this. So let's get the sine wave. So for the voltage, I'll use this for the voltage. The voltage is always in front, okay? The voltage is always in front. The voltage starts faster than the current. So by the time the voltage has peaked, that's when the current will start moving. So we are going to have this. Okay, so you can see from here, this represents the voltage V of t is equals to V naught sine omega t, and the current I of t is equal to I naught sine omega t minus pi over 2. Okay, so if you are conversant with with sine and cosine rule, you will understand that this here is exactly what the negative of what the cosine rule. Okay, so next the phasor diagram is going to look like this. So we have the VL on this side and the IL on this side. So you can see that they are 90 degrees out of it. So this is the phasor diagram. The phasor diagram is a vector diagram that represents the magnitude and direction of the what current and what voltage. So let us look at a capacitive circuit. So a capacitive circuit is a circuit that contains only a capacitor. So again, we draw this. Okay, so we have the voltage and the frequency as usual measured in hertz. So this is a capacitor. So the current flowing will be IC. Okay, now for a capacitive circuit, the current this time around leads the voltage. Current leads voltage, or you can say that voltage lags current by 90 degrees. So they are also 90 degrees out of phase. Okay, so the instantaneous voltage will be given as V of t is equals to V naught sine omega t as before. Then the instantaneous current I of t will be given as I naught sine omega t plus pi all over 2. Now you can see that I'm using plus here because it is actually faster than the voltage. It is ahead of the what? The voltage. Now you see that in all the three circuits that I've explained, I did not alter the instantaneous voltage. It is only the instantaneous what? Current. Okay, so next we can look at the reactance. So the reactance is going to be SC. That will be equal to 1 over 2 pi FC. So you can see the difference now, or 1 over omega C. Okay, 1 all over omega C, because omega is equal to 2 pi F. So if I draw the phasor diagram, it's going to look like this. So this is going to be IC, and this is going to be VC. So you can see that the current leads the voltage by 90 degrees. So this is the reactance. So you can also calculate the reactance from IC is equals to VC all over IC. That is the voltage across the capacitor divided by the current across flowing through the capacitor. So this is an introduction to AC circuit. We'll take some examples. Then before we move to a combination of two or the three of the what different type of circuit. So we'll take an example now. Okay, so let's take this example. The current I in an AC circuit is given by the equation I equals 30 sine 100 pi t, where t is the time in seconds. Deduce the following from this equation: frequency of the current, peak value of the current, RMS value of the current. So what we need to do, let's write this out. So I is equals to 30 sine 100 pi t. So you compare that to this. I of t is equals to I naught sine 2 pi ft. So you compare that. So when you compare that, this is the peak current. Okay, the first part is so you should look for the frequency of the current. So to look for the frequency f, let's look for that. So we just compare this and this. So it therefore means that 2 pi ft will be equal to 100 pi t. So from here, you divide both sides by 2 pi. So f is going to be equal to 100 pi t divided by 2 pi t. So you see that this will cancel out this. And when this goes here, we have 50. So the frequency is equal to 50 Hz. As simple as that. Then the next, we have to look for the peak value of current. To find the peak value of current. So to find the peak value of current, I naught, you just compare this and this. So that will be 30 amp. Okay. Next, the RMS value of current. Here we are going to, so this answers 2. So for 3, we are going to use the formula I RMS is equal to I naught divided by root 2. Remember this formula. So I naught is 30 divided by root 2. So you can press this from your calculator. 30 divided by root 2. So that's 21.21. So that's equal to 21.21 amperes. So that's the RMS value of current.